Hey folks, East of Eden grower Creedmoorfury coming to you from my happy place. I'm in my compost tea zone right here, just above my main garden. It's a beautiful Tuesday afternoon, and I've got some information to share with y'all, some information to share with some of my friends and those who hopefully will become friends. Anyway, the nature of today's story, the nature of today's content is lactic acid bacteria. Not long ago, one of my growing friends asked me, they said, hey, Creedmoor, I'm having some problems with powdery mildew on my plants. Do you know a simple way for me to mitigate that? And, well, my answer to that wasn't necessarily a simple one, but I did suggest that they go ahead and make some buttermilk or make some butter and then take the buttermilk because I was already aware of the fact that the dairy industry already puts lactic acid bacteria in the milk as a biosterilant. Yeah, they put it in the milk, they put it in cream, they put it in all of that stuff. So it's pretty important stuff. It's good stuff because it makes it so that the milk is going to be safe. It's homogenized and it's been safe. It's pasteurized and it's been safe. Okay, so from this position, you can see pretty much everything that we're going to be utilizing in this particular formulation. On the left is organic dextrose. That's a type of sugar. And I always try to select an organic version. Just to the right of that, it says FAA. That stands for fish amino acids. In this particular case, it's a fish hydrolysate that I made. We have videos on that as well. And to the right of that is apple cider vinegar, which is also a catalyst, and that contains potassium. And that particular version does not have the mother. If you zoom in on the video, you'll see there's no mother on the bottom. So we're not going to use the mother. I don't want to add too many additional microbes outside of the labs because I want the labs, the 2 or 3 versions of labs that are in there, to be the dominant culture. Okay, to the right of that, you can see a container of True Lemon. That's actually citric acid, and we need that. And to the right of that, you can see pure Castile soap. It also has some citrus in it. And the one and final last catalyst that we're going to be utilizing today is Epsom salt. Epsom salt contains magnesium. Using these in fairly dilute amounts, and basically what you can see there is this little tiny little fluorescent color tags indicate the percentage of the resultant and finished and complete solution that needs to be represented by those amendments. So I can go over them one by one and show you right here. This organic dextrose represents 2% of the total amount of this. Fish hydrolysate will also represent 2% and 2% ACV. 1% of this citric acid, 1% of this, in this particular case, this is a surfactant, and it is soap. This is Dr. Bonner's soap, Castile soap. Y'all have seen it before. We've talked about it. And finally, we have this Pennington Epsom salt. We're also going to be utilizing 1% of this, 1% of this, and 1% of this. And this is 1% of 1 quart. This is 2% of 1 quart, 2% of 1 quart, and 2% of 1 quart. So really what I'm saying to you is these things don't have to be 2% of whatever it is that they are. They're going to be and represent 2% of the final solution, which brings me to that part, because mathing is what really confuses people. I know it confused me as well back in the day. Now, not so much. But that's why I want to show you this little device right here. This is a ring of spoons. Some of y'all may have these in your home. This particular version is stainless steel. And I will call out what each one is, one by one. This one right here is 1 teaspoon. This one right here is a half a teaspoon. This one right here is a tablespoon. It's stamped and embossed into them, so I don't forget. They do that for me. And this is how simple this is, because when we're working with this volume, we want either 1% or 2%. So in this case, if I want 1% of this volume, I'm going to slide this half teaspoon to the left and pair it with the teaspoon. And that right there represents 1%. Close enough, okay? I've told y'all in previous installments of my content, Mother Nature doesn't measure things precisely, so neither do I. Okay? Good on that? Now, if I want the 2% ratio, I slide this half a teaspoon doohickey over here, and that's about all I need. That's it. That's it. So if it's 2%, we're going to use it this way. If it's 1%, we're going to use it that way. And all I'm going to do is work through each of these ingredients and put basically that amount right in this container. Make sense? First things first. Attempt to open this. Give you all an idea. This is what dextrose, organic dextrose looks like. I buy it in bulk. I keep it sealed in this container to keep things out of it. So this is going to be 2%. So all I'm going to do is basically grab a level tablespoon. And really, folks, we're making food right now. This is food. And then I'm just going to grab a tiny bit more because it should be roughly 1.25 tablespoons. That's what we're after. And that's close enough. All right. So that's it. That's all we need for that. I'll go ahead and I'll zip this back up, fold it over, close it up to keep the bugs out. And that's a wrap. Okay. Now, fish hydrolysate, it has a relatively acidic pH. And all of the items here have some form of a buffering value to them. So we're going to go ahead and move right on down the line. This is amino acids and proteins as well. It has calcium. And there, just like the dry measurement, we're going to do it the same way. We're not looking to overflow this stuff. I'm going to go ahead, put one more in there. And that's it. That represents the 2% we're after. And I will follow with ACV. It's preferable to use organic things. So if you can get organic ACV, it means that there's probably no glyphosate or isopropylamine salts in it. That's the way it works today. I'm sorry if y'all are just seeing my hands. It's probably more appropriate anyway. If you want to zoom in, you can basically get an idea. I'm not trying to be super precise. I'm not, folks. Just not. Okay, so I'm going to go ahead and switch over. We're going to work this 1% side of things now for a second. And I also want to mention while I'm working through this, folks, there are alternatives to all of this stuff. Okay? You don't always have to use the same things. Here we're going with some citric acid. I mean, I really do not try to make this super precise. I just don't. I don't care to. I think if you ask the microbes, they would say it doesn't really matter. Okay? I just want to take 1 second to talk about citric acid. Citric acid is really important for gardening because if you happen to live in a city and you're receiving your water from a municipality, that water has been chlorinated or possibly had bromine or some other ene added to it to sterilize it and sanitize it for delivery and so that it can be used safely by us. Well, chlorine's not safe for your plants, and I wouldn't recommend putting chlorine in and expect to make lactic acid bacteria. So if you do have to use water in something like this, you don't want to have chlorine water in it because it's going to kill all the labs. Chlorine is a sterilant, and it does kill bacteria. Well, we don't want to put that type of a sterilant in the garden. So when we're watering our gardens with chlorine water, we're actually applying a sterilant on a fairly grand scale. So this is the mitigant for that. If you happen to have to grow with chlorine water, just a small pinch of citric acid is really all it takes to mitigate it in a pinch. You can do a gallon, 5 gallons, or 500 gallons. It's all scalable. As you can see here, everything's scalable. Okay, we're done with that. We're done with that. I'm going to go after this surfactant, just a small amount of this as well. We're just going to put that soap in there. That's all it is. Surfactant is just a soap. And I do want to stress how I'm totally not trying to be super precise. I don't want you to think you need to be bound to precision. It's not necessary. I mean, I've made this stuff using the right stuff and the wrong stuff. And when I go ahead and I look at it under my microscope, I see active bacteria. And that's really what we're after. There we go. Okay. So this is it in the end. I mean, all we did was basically put a little this, and this, and this. And that's your catalyst. Okay? That's the whole entire catalyst right there. That's all it takes. What I'm going to do is I'm going to go ahead and put a little tiny bit of water in this just to get everything to dissolve. Then it's going to get mixed into that, and then we're done. Okay? So I'll be right back. Put that lid right on there just like that. We're going to give it a good shake. Another good quality protein source, if you don't have fish hydrolysate, you can use whey, organic whey, if you can get your hands on it. You know, you can use cheese. There's all kinds of things that you could use. You could use a little piece of meat. I mean, in this case, I used the fish. And you look at it and you say, well, it's not mixed up. It doesn't have to be mixed up. They're in there. That's all they need to be. And now we're going to take this and put it in that. And we're done. That's basically all we have to do. I'll go ahead and I'll shoot this and you'll see it's not even warm because it was in the refrigerator a while ago. So I don't expect a whole lot to happen in the next few minutes. But as this starts to warm up, we'll start to see what's going on inside it. You'll be surprised. I'll cover that later on. So in closing, it only takes 4 or 5 different items to add as a catalyst to encourage the lactic acid bacteria to eat, fortify itself, and then multiply itself in this solution. Okay? Within a few days, this will start to really, really break down and ferment, and I'll start to see the evidence of that on the top right here. So that's where I'm going to be looking right here. Every day I'm going to check on this to see exactly what it looks like. I'm looking to see the change. Well, essentially, a lactic acid bacteria mother will form. And then we're going to utilize this very small amount at a time. I like to use maybe a tablespoon per gallon of water, and then I can drench my plant's roots, and I can also use it as a foliage cover. And if I'm going to use it as foliage cover, sometimes what I'll do is I'll mix it up, and then I'll put about a half a teaspoon of Castile soap in it. And that surfactant helps it to stick to the leaf. So if you have powder mildew, you want the organism and you want a surfactant, because the surfactant is going to be what holds it on the leaf, covers the leaf sufficiently, gives it full and thorough coverage. It's going to impact stomata on the bottom of the leaf. It's going to actually work in a systemic way to achieve your goal of destroying that particular pathogen. So at least for now, we're going to put this on a shelf. It's going to stay out of the sun. It's going to go about its business and it's doing its thing. I'll check on it every day to see how it's going. We do not need to crack it open and let it breathe. Anaerobic means it doesn't need oxygen to do its job. It will be using other things in here to metabolize. And that's basically it. Okay, so if you've never made labs before this way, give it a try, see if you like it. Tell me about the ways that you make labs. Tell me about other ways that you make labs. You have the KNF form of gardening, JADM method of gardening, and both of them recommend some different ways of producing lactic acid bacteria. I also practice those methods, but I settled on this one. Peace, folks. God bless.
Okay, well, here's an update to, of all things, the lactic acid bacteria culture that I've been making. It's been fermenting for 2 days, and that's usually when I start to see some good confirmation that the species is multiplying, and there you have it. See the color above the top? At some point all of this will be pretty much more brown like that. And for me and my own confirmation standards, I'll be taking a small amount of this liquid and putting it underneath my microscope for examination to make sure we have rod-shaped bacteria. We do.